Hello, hello, and welcome to another edition of Spindle TV. My name is Laney Shaughnessy. I'll be your host this evening, and joining me tonight on camera we have Ronnie and JR. Ronnie and JR, for folks that are watching tonight, Ronnie and JR is one of many of the Spindle TV exclusive members. They're gold members of Spindle TV exclusive, and with the gold members, it allows them to kind of come on and join me live when presenting and things. And so, for those of you that are watching, we have a membership program with Spindle TV channel. We have silver members and we have gold members, and those members get exclusive, behind the scenes content. They get some one-on-one time with me. They get access to a special group, and we do live classes every Wednesday night just for members only and things. So there's a lot of cool benefits and things like that. If that's not something that interests you, there's a join button on the Spindle TV channel. Check it out. But Ronnie, JR, how you doing this evening?
Yeah, wonderful. Thanks for asking.
Yeah, awesome. We were just Ronnie and JR and I were just chatting in the background before we started the class, talking about different setups and things. And the topic tonight, ladies and gentlemen, we're going to be talking about something that I'm hoping adds to your knowledge and repertoire and doesn't confuse you, for those of you that are just getting into CNC and certain things, and you're used to doing things a certain way. This is just meant to be information. It's not a required, like, do this and don't do that kind of thing. It's just some new stuff. We're going to be talking about working with your CNC's offsets, your coordinate positions, different coordinates. We're going to be talking about parking positions. We're going to be talking about homing procedures. And we're going to be talking about machines that can be homed and machines that don't get homed because they don't have limit switches. And we're going to talk about some different things that we can do to kind of create a home position on our CNC machines that may be beneficial to us or allow us to utilize some of the benefits that our controller programs provide for us for our machining and stuff. So we're going to be talking about all that, and I think it's going to be a good class tonight, and I think the topics are going to be pretty interesting. What I'm trying to do, give me just a quick second. I am trying to find a video file that I recorded and I can't. Oh, I know why I can't find it, because I'm looking in the wrong place. It's in the wrong place, ladies and gentlemen. I'm such a goober sometimes. Okay, here we go. I found it. All it takes is just knowing your stuff, knowing where your stuff is, not knowing your stuff. But let's see here. Let's go down. There's the... All right, so the year is 2024, and let's go to... All right, ladies and gentlemen, stand by. I'm a goofy. We'll do this. All right. On my that picture's blurry. We're going to use this one. Okay. On my in my shop, I got a very small shop. It's wall to wall. It's tight. We're going to switch over to a big screen. JR, Ronnie will catch you in just a little bit. Let's go big here. Let's switch me over, or all of you over, to my screen number 2, and let's get me down in the bottom left corner. There we go. And one of the things that I have going on is I have been fortunate enough that I have 2 CNC machines in my shop. Way back in the back corner behind everything where you can't see everything, there is a 2440. That is the machine that I have run on since 2014, and I make almost everything on that. And recently, I was fortunate enough to come across one of our customers that needed to, they were moving, they needed to sell one of their machines or their machine. And I was able to get one of our 4848s, one that Digital Wood Carver, works with and manufactures and stuff. And I was able to get that at a good deal. They were very fair on the price, and I was able to bring that into my shop. And now with that, I now have multiple tables that do multiple things and multiple operations and stuff. And what I want to talk to you about is coordinates. So if we look at this CNC machine, this is a 48 by 48, meaning the cutting area is 48 inches by 48 inches. And on this machine, when I first started with it, like you can see in the picture, I have a board just clamped right in the middle of the table. And, wherever I clamped my board is where that was my work offset, and that's where I carved from. Now, if you were to look at my CNC, it is divided up into coordinates. And those coordinates allow me to I have jigs mounted on my CNC. And unfortunately, I didn't grab a picture of that, but I have jigs mounted on my CNC in different positions. And those positions are cordoned off. So I have my coordinate system 1, my coordinate system 2, and coordinate system 3. And when you're talking CNC, regardless of what your controller system is, and let's get out of this picture for a minute. We use at Digital Wood Carver, we use a program called Planet CNC TNG. Whether you're using Mach 3, Easel, Planet CNC, Carbide Motion, or any other controller program and things, the one thing that we all have in common is by default, when we open up our controller, our default setting for our coordinates is G54. So I don't know if you can see right above my head in my active G code screens here. Let me see let me see if I can, y'all see what I see. Okay. We see this G54 right here. Now this is telling me that I'm in my main coordinate system number 1, let's say. Now there's G54, G55, G56, G57, G58, and G59. Now once you get, so there's 6 main offsets, let's call them offsets, that you can use, different coordinate systems. And once you get to past those 6, that G59, then you can go more, but it's G59.1. G59.2, G59.3, 0.4, 0.5, so on and so forth. So literally you could set all kinds of different coordinates. And what this is on this in G54, my home position, my coordinate system is here where my limit switches are. That's my X0, Y0, right? And let's say that I go into my machine's configurations, and you would have this too. I'm not sure, like on Mach 3, what menu it's in and everything. I believe it's in the offsets menu. I think they actually have an offsets menu. But for us in Planet CNC, we come down to a thing called coordinate systems. And in coordinate systems, I'm currently in coordinate system 1, but I can go 1 through 9, right? I can set up to 9. So after 6, which is G59, then it's going to be G59.1, 0.2, 0.3 kind of thing. But I'm in coordinate system 1. Now, when I am in my coordinate systems, I can actually specify the XY0 location for that offset, for that coordinate. So on my left side of my table, I have one jig, and the coordinate system for that jig is G54. So I could come in here and say, okay, in this coordinate system number 2, we'll call it number 2, which is G55, I'm going to call this my my box making jig. We'll just call it that. And the offset, the coordinate, now I always on the Z, I just, I set the Z, about 2 inches up. But on the X and Y, let's say that on my X and Y, that coordinate system is 36 inches on the X axis and 1.5 inches on the Y axis. When I add that to there, it adds it to my list. And so let's go back to coordinate system 1. We'll just call this my main coordinates, my main offset. We'll call it my main offset. And it'll be, let's go 0.5 for X, 0.5 for Y. And again, I'll just go 2 inches. That way, when it's traveling from, one coordinate system to the other, it'll go 2 inches up in the air, right? It's not scratching across the table or anything. All right, so let's say that I have these two coordinate systems here and everything. And so currently, right now, I'm in G54. Now, in my software, just like in yours, there's ways that you can automatically switch from one coordinate system to another. And for me, I can do it one of two ways. I can go to my machine menu, coordinate system, and I can select coordinate system number 2. Now, I want to zoom out. I want you to see what happens on the screen. Let's kind of get out here and everything. And let's switch back to coordinate system number 1. So you can see my XY datum. That's that red and green arrow right here. This is that 0.5, a location from my machine 00. Right here is my machine 00. And this is my first coordinate system. This is my machine's home position for the coordinate number 1. Now, when I switch over to coordinate system number 2, you can see that my datum switches to that 36 inches and that 1.5 location. Now, if we were to tell my machine to go to that 00 position, I want you to see something. And let's back up 1 second. I need you to visually see all this as a whole so you can understand what's happening in the back end. Let's go back to coordinate system number 1. And so when I run my machine's home procedure, it lands at the end of the home procedure when it's all run. It lands at 0.5 on the X and 0.5 on the Y. And let me do this. X 0.5, Y 0.5, and hit enter. So that way my router moves to that location, right? And so the work position, that's where I'm at, right? So that's that. Now I actually want my machine position to be there too. We'll talk about why in just a second. Okay. And so when I'm here and everything, if you look, for that coordinate, G54, that coordinate system, that offset, that's my 00 position for my work offset. That's my 00, unless I change it. If my board was clamped on the table up here somewhere, and I moved over to that position, and I zeroed out my X and zeroed out my Y, you would see my work offset move to that location. And my machine keeps track of where it's at. So currently it's at 4.3656 inches on the X and the Y. That's where the machine is at, but that is my work offset, my work zero position, right? Now, if I switch from coordinate system 1 to coordinate system number 2, and I come over to machine coordinate system and I switch over to number 2, you will see that my coordinate system machine position is here. That's that 36 and 1.5 that I designated. And my work offset is here because it thinks that I'm working off that same work offset that I had before. And that wouldn't probably be the case. But if you notice here, it says that currently I'm sitting at negative 35.5 inches and negative 1 inch. That's because my router is still way over here on the table. And so moving to the left, X negative, and moving down, Y negative, that's why I'm at that negative position. If I told my machine to move back to 0, it would move back to 0 of whatever coordinate system I'm in, whatever offset. So for every jig that I have clamped on my table, the corner, for me, the bottom left corner of the jigs on the left side of my table are my 0, 0 for those jigs. And on the right side of the table, it's actually, I use the bottom right corner because I want my jigs on the right side of the table to be as far over as they can, to where I'm not crashing into my limits of travel, but I'm just off of it. But I'm starting from the right, the bottom right corner of my job setups and things. And so when I switch, I can switch by using the menu, or I can use what's called the MDI box, the MIDI box, manual data input. You guys and girls all have a MIDI box or a manual data input box somewhere within your software, your controller software, where you can type in a coordinate and you can tell your machine to go there. Well, not only type in coordinates, but down at the bottom corner of this software, I can type in G54 and I can hit enter. And it switches me back. If you look at the active G codes here, it switches me back to G54. If I type in G55 and hit enter, it switches me to G55 in my active G codes, and it switches me to that coordinate system. So I can tell it what coordinate system I'm working in. And I can even set that up in my Vectric post processors. So in my post processors, I can put in the parameter of G54, G55, G56, 57, 58, 59, whatever. And if I'm creating a particular project that's going to be off of one of my jigs that's on a certain part of my table, and it doesn't always have to be jigs on your table, just if it's a certain part of your table. If I want to work on the right side of my table or the back side of my table or the left side of my table, I can set those coordinate systems. And I can choose the correct post processor that automatically has that, that G code of G54 or G55 right in the header, so that when I load that toolpath, as soon as I hit start, it knows that I'm working off of this coordinate system, or I'm working off that coordinate system. So I'm working off this position on my table, or I'm working off that position on my table. So it allows me to take a table that I can designate certain parts of my table to do certain tasks. And I can specify where the location of those areas are, where the 0, 0, the machine position for those locations. Those are called offsets, right? So we can use offsets. And if we were to go look at a G code, so if I come in and let's go to Vectric File, open application data folder. Oh, it opened on the other screen. There it is. Let's go to my post P, and let's say that we'll go with this one here. I will right click and I'll edit it with Notepad so we can see it. Notepad++. And so coming down in the header after the file section and all, I could put right here, I could put my quotes, G55 quotes, and that would be the very kind of the first line of my G code. And so when I load that G code and everything, it immediately knows I'm working in, G55 coordinate system number 2 or G54 coordinate system number 1. So I can edit my post processor so that when I save my toolpath, I can choose whatever coordinate system I want to work off of. I can choose that. And I know what the coordinate systems are for my table because I set them up, right? So you would know too, and everything. And you can make that part of your G code right off the gate. Now, you don't have to do that, but you could. What you definitely do have to do is in your controller software, whatever it may be, you need to switch to that coordinate system either manually or automatically through the G code, right? So I can switch by typing in G54 or G55, or I could come up to my machine menu, my coordinate systems, and I could select whichever coordinate system I want. And I can name and set up to 9 coordinate systems in my program. And things. And each one of those, if I go to edit them, like I said, each one of them has a offset, an X, Y, and Z offset. Now we're, of course, setting our 0 on the center of our board or the corner of our board or the corner of our jig or whatever it may be. And we're zeroing out X, Y, and we're touching off Z, right? So the Z coordinate of 2 inches doesn't matter. That's just, how high the router is going to go into the air when it's moving from one coordinate location to another. Okay. All right. So I would love to be able to let me look at my phone and see if I just didn't upload it to the cloud for tonight's class. Give me 2 seconds here. Let me look. And if I can see it here on my phone, then that simply just means I didn't upload it to the cloud. And it's under the date of August 30th. So, okay, wonderful. I know exactly where it is now. So let me go in and I'm going to pull it over on the screen so you can see what I'm talking about. So we're going to go to Spindle TV and we're going to go to media and we're going to go to videos. All right, I'm going to mute this so we're not listening to music, and I'm going to bring it over on the screen so everybody can see. All right, so hopefully everybody can see now. Now, on this left side of my table is one jig, and I have a wasteboard. I have an MDF wasteboard. I have threaded inserts in my wasteboard that my jigs screw down to, so they can be removed. The jigs can be removed from the table, so I can use the whole table to cut stuff and all that and everything. But when I want to put the jigs or mount the jigs back on the table, they mount back into their threaded inserts right back where they belong. Now, what you're seeing on the screen, I'm going to play just a small bit of the footage. This particular jig makes cat windows. So let's skip to the end for a second. And basically, we'll skip to the end so you can see the product. But it's basically these little cat bed window hook type beds for sitting outside. And that's what the jig on the left side of my table, this particular jig that's set up on the left side of my table, it makes these products, this particular product. And so if we go back, what is occurring is in this jig, the parts, I cut the parts out of my boards on my table saw. I cut all my blanks down. They're sitting on a shelf. They get popped into these pockets on this jig. And then the machine is zeroed out on the bottom left corner of that jig, and it runs these parts. And as those parts get cut, they get removed and other blank parts come in. Now, if we pause right here, let's pause. Let's not pause there. Let's pause. Come on. Right about, let me get away from the close-up. That one's, that was almost a good one. Let's go here and let that play for just a second and then pause right there. Now, on the right side of the table, you see these HDPE parts, HDPE, high-density polyethylene. This jig on the right-hand side is the jig that I use to make my dust brushes, my 4-inch dust brushes for CNCs. And so that jig is coordinate system for me, coordinate system number 2. And all the parts that make those dust brushes and everything are made on that jig. So I have different production going on of different parts and things, and these jigs are mounted to the table. And so I'm either working on coordinate system number 1 or coordinate system number 2. And it's a way to, I can get exactly right. When I tell it to go to coordinate system number 2, it knows exactly where that 0, 0 position is for the corner of that jig. And then I can set my work offsets, and it's dead on. I don't have to guess. I don't have to, do anything. It's right there where it needs to go. I've set that. And it's a very useful thing if you're trying on a small shop or a small situation, if you're trying to create somewhat of a production environment for yourself, and you don't have a big table, or you don't have a lot of room, or you're making small parts, and you've got a little bit of room on your table where you can make bunches of your small parts all at once and different, just by having, a certain, like my coasters could be a jig, my coaster holder that covers my coasters could be a jig on my table, and I can set these coordinate systems. Now, what you don't see is right now in this video, these 2 jigs are very big jigs. They almost take up the whole, well, the one on the right is literally, I think it's 28 inches wide by almost 42 inches long, which is almost the whole length of this table's cutting area and everything. Well, those threaded inserts, there's threaded inserts set every 2 inches on center on my table, in my wasteboard. I have threaded inserts every 2 inches on center. And just because that whole jig covers up that whole right side, and that's coordinate system number 2, about halfway down my table, I have coordinate system number 3. And I could take that jig off the table. I could put my other jig in place and screw it down in its threaded insert area and everything. And up on my table, up and over, 36 inches over, I think it's like 28 inches up or something like that. That's the 0 position for that little jig. So I have multiple jigs, and when I'm not using them in Florida, I got a problem with things warping and all that stuff. So I have this kind of upright vertical that my jigs will go into, and they get clamped so they stay flat. They have no room for movement, on edge and stuff. And because if I just lean them on the wall, they'll get a sag. If I do this, if I do that, so they go into a certain spot. It's almost like it's not pull-out drawers, but it's almost like it's just like a rack, if you will, that my jigs go in, and I can clamp to keep them flat and everything. So coordinate systems. I want you guys and girls to look at your controller programs and figure out where you would go to set your coordinates. Look at your manuals and stuff for your G54 through G59, right? And then you can also see if your program allows for more than the 6 by 59.1, 2, 3, which it does. Now, the next thing I want to talk to you about is in your controller software and stuff, you may or may not from time to time see a button in your software that says G28 or G30. In our software, we have G28, move to G28, G30. Now, in G code, that is go to home, right? That's kind of a home position. And technically, my machine's home position, I could set that 0, position as G28 to create, to tell it to go home. But I actually use it as I use G28 and G30 as a parking position. So if you ever, when you're carving your projects and things, you ever wanted at the end of your job, you're carving and all, and you want your machine, when it's finished carving, you would like it to raise up and move to a certain part of your table. Just go to a certain part of the table, move out of your way. That's a parking position, and that can be set as a G28 or G30. It can be set as those positions. So if I, on my machine, if I told my machine to go up on my y-axis 36 inches and on my x-axis, and let me change something so y'all can see what I'm typing, because right now, and I'm typing in the bottom right corner, but the numbers are pink and you can't see them. So let me go into the settings. Let me go down to my jog. Let's see here. Come down, utilities. I'll get it here in just a minute. There we go. Let's change that to black. I don't know why it's set to pink. There we go. And click OK. So what you should see in just a second is down in the bottom right corner, you should see that Y36 that I have down there. And let's go Y36 and X. Let's go X3. Right, X3, that's fine. And so when I move over to that position and everything, I have a couple of ways that I can set that position as a G28 parking position or go-to position. I have a couple of ways that I can set it as a G28 go-to position or a G30 go-to position. One, I could just type in G28.1, and that'll set whatever coordinate I'm at, wherever I'm at on my table, it'll set that location as G28. If I type in G30.1, it'll set it as that. Now, instead of typing in the code, I can simply go to machine, my machine menu, machine position, and I can just click as G28. So when I click that, it sets that coordinate to this button over here, move to G28. So if I were to go back to my X0, Y0 position, which is, you'll see this little yellow dot. You might see that yellow dot traveling there. That's going to be this position right here. I can then, if let's say I was carving and I wanted my router to move out of the way, I could come over here and set G28 or click G28, and it's going to move to that coordinate, which for me was, what was it, 5 and 36 or something like that, or 3 and 36? Yeah, 3 and 36. So it's going to move to that position. Just move out of the way, right? Now, its normal intention, it's a go-to home position. It's if you wanted to set a particular spot on your table as a home position, you could set that as a G28 or G30, and that could be kind of your home position. Well, for me, I think of it and I use it as a parking position. So I tell it to go to, a certain location. So if we were to look at the Vectric software and everything, in the Vectric software, let's assume that this is my table here. My main coordinate system by default is G54, and my home position is the bottom left corner. On my G55 coordinate system, I'm using the X and Y position here, and it's, for me, anything that's in G55 is running from the bottom right corner as my datum position, G56, G57, and then I have a G28 parking position, and I have a G30 where my machine will go over to that location, or it'll go just in the middle of the table, right? So I can set those types of coordinates and stuff. Now, here's the kicker, ladies and gentlemen. The machine has to know where its home position is. So most CNC machines, commercial machines, will have limit switches and homing procedures. Click a home button, the machine raises up, it moves a Z to its limit switch, parks itself, moves its X to a limit switch, parks itself, moves its Y to a limit switch, and parks itself. And where that parking position is, that is its home position, the machine home position. Now, if we were to look at the back end of my controller software in the settings, and we were to come down to home, in the homing procedures here, my limit switch positions for X and Y are 0, and my Z is 8.67 inches up. And when it touches those limit switches and everything, it then moves to 0.5 on X, Y, and it moves down to 7 inches on the Z. And that's the machine's move to its home position. So after it homes itself on the limit switches, it moves to that position. And which is this location right here. Now, this red and green arrow you see there, that's my work offset. If I were to clear out my memory right now, my work offset, clear that work offset, you would see that that red and green arrow move back to that 0.5 position and everything. And notice that the here, if I zero out where the yellow dot is, that's my limit switches. That's 0, 0. And when after it touches off, it moves to X 0.5, Y 0.5, and then Z7. It moves to those locations. And I don't know what I just typed in. Let me stop there. I have no idea what I typed in. Let's try that again. X 0.5, there we go. Y 0.5 and Z7. All right. I did not reach my machine. Oh, give me a second. I had a work offset. Sorry, ladies and gentlemen. I'm being silly now. Let's make sure I'm back in G54. Okay. Let's try that one more time. X 0.5. Y 0.5. Perfect. Z7. Now, if you're wondering why it's the yellow dot is up here versus the datum here, and I did not reach my machine limits. It's just I'm in simulation mode, so I'm not able to home. So it's thinking I'm hitting my limits. But if you're wondering why I'm here, because everything is based off the work tab, and that's what we're gonna get. That's what we're getting at right now. Is for those machines that have limit switches and everything, When you home, you have what's called your machine's position, your machine's absolute position, right? Your machine's home position. And where your workpiece is clamped on your table and you move over to zero out your X, Y, and Z, you are setting your work offset. Now, many of you, especially if you're digital wood carver customers and you're watching this and everything, and you have our 1824 model or our 2440 model, you've never operated from the work tab. You always just stayed in the machine tab because you work off of what's called a variable home position. You clamp your board on your table, and many of you might do this as well if you have a hobby or small units that don't have limit switches or something. But you clamp your board on your table, you move your router over, you zero out your X, you zero out your Y, you touch off your Z, and that's your home position. And that home position, that XY0, whether it's in the center of the board or the corner of the board or what have you, it's variable. It's really kind of dependent on where the board is clamped on the table. But for machines that have limit switches and things, their limit switches, when they run their home procedure and the machine runs back to its limit switches, it's going to move a distance off those limit switches and things. And that is the machine's absolute position. That's the machine's home position. And from there, the operators of those machines, they're operating from the work tab or the work position. And when they zero out on the center of their board and they touch off on the top of their board or whatever the case may be, they're setting their work offsets. And so they work in two different tabs or two different locations. You have your machine location and you have your work location. And the machine keeps track of itself because you may have what's called soft limits set up that this machine has a travel of 40 inches by 24 from its home position. And so 24 inches, when it gets to that 24 inches, it stops itself and says, hey, you've reached your machine limits. Well, like that little box that kept popping up saying you've reached your machine limits. It stops itself. Now, if you don't have a fixed machine position and you have a variable home position where you just clamp your board anywhere on your table and you're zeroing out X, Y, and Z, you're not really setting a work offset, then you have a little bit more potential that if you tell the machine from your center of your board to move over 24 inches, depending on where that board's clamped on the table, if that 24 inches exceeds the travel, it's just going to try to go and it's going to lose its steps. It's going to hit. It's going to lose its steps. So you're going to have to reset X and Y and things like that. Well, I'm here to tell you, it doesn't necessarily have to be that way. Regardless of if you have limit switches or not, if you don't have limit switches, and let's focus on you don't have limit switches and all, you can set a fixed position on your table that you work from for your machine position. You can, on my 2440, before I installed limit switches on my DWC 2440 model CNC, I used to use my fences. I have a 90-degree fence on the bottom left corner of my table where the operator stands, my X0, Y0, my bottom left. I have a fence system that all my boards would reference up against. I could even clamp out in the field, but I would be setting that work offset. But I have a known position that I can zero my machine out at the beginning of every morning. And what I did was before I purchased just recently, what was it? I don't know if Jerry and Ronnie were in the class, but I was showing them these 1, 2, 3 blocks that I had just gotten in from Win out of Amazon. Win, W-E-N, 1, 2, 3 blocks. Precise as all be it, man. I mean, they were just dead on 1 inch, 2 inch, 3 inch. So if you don't have a set of 1, 2, 3 blocks in your shop, go to Amazon and get some. They are phenomenal. But I didn't have 1, 2, 3 blocks at the time, but I did have a block that I always used that I could set in the corner of my fence, my little 90-degree fence and everything. And I can come over and kiss the bit up against the side. I should be able to spin. I always have put in a little dowel rod, or if I didn't have my dowel rod, if I couldn't find it, I took my 60-degree V-bit and turned it upside down, but a smooth shank basically. And I was able to kiss up and tell the CNC machine that I'm at this location on X, move over, and I'm at this location on Y. Now, I also have, I could do that with what's called my DWC Quickset zeroing block. It's a little 3-inch by 3-inch aluminum block. That's a sensor I can touch off, and I could set my X, Y, and Z zero. So I could always work from a certain position on my table as my fixed position. Now from there, there's some benefits. From there, I can go into the system, and again, Mach 3, Carbide Create, whatever the case may be, and I can set what's called limits. In this case, for my 4848, my limit of travel is 48.25 by 48.25. From that fixed position. And so if I tried to move my machine to 49 inches, instead of crashing, it would stop itself and say, hey, you've reached your machine limit. So it was really great that I wouldn't lose my X and Y coordinates. I just back up and, resize my board or whatever the case may be, whatever that situation is, and everything. And so this long drawn out explanation is to say, for those of you, I'm not saying change what you're doing right now, but there are some benefits, more than some, there's quite a few benefits from working from a known position on your table. So it's basically that if you're an operator and you stand at the front of your table and you load everything from the front of the table, X is to your left and right, Y is to you and from you, that lower closest left corner as far as you can go. And for me, I move basically as far as it can go to where it can't move anymore. And I'm off that X and Y by a 1/2 inch, right? So when I zero out my machine, I'm a 1/2 inch away from my absolute limit of travel, right? And so from there, I can now set my Y coordinate. Let's say I have a 40-inch cutting area. I'll set it to 39.75 or 39.5. Not 3/4, because that would be further than my travel. But I could set that, and then over on my 24 inches, I maybe set it to 23.5 on my limits. And if I activate them, now my machine keeps track of itself, and instead of crashing, it stops itself. So what that looks like for me is, if I told my machine right now, if I said X 50 inches at a feed rate of 300 inches a minute, and it starts traveling across, let me zoom in here. It's going to travel, and then I'm going to get a message. The machine's going to stop itself, and I'm going to get a message saying machine limit reached. Right? It let me know that I've gone as far as I can go. It's a soft stop. It's not a hard stop. So it stops itself before it crashes and you lose your coordinates. So I could simply just say, okay, and I could just return back home. I haven't lost my XY coordinates and things like that. So I can set what's called soft limits. Soft limits means there's no physical switch there stopping me. My software is stopping me based on my settings, based on my machine's zero position and where I'm going. Now, let's say that I create my work offset, right? So I come into my work tab. I'm going to move up on the table. I'm going to go halfway up and halfway over, right? So let's get kind of halfway up and halfway over, something. This will be close enough. Now, let's say that this was the center of my piece of wood, and I zero out my X, I zero out my Y, I touch off my Z. Now, on my screen here, that red and green arrow, that's my work zero, my work offset. So that, where that yellow dot is, that's my work offset. Now, I absolutely do not have room to go 48 inches. I'm already, if we look at the machine position, I'm already 24.5 inches over, right? The machine is now able to keep track of itself because it knows where its zero position is, the machine's absolute zero position. And it keeps track of its absolute position. Even though I'm at my work zero, the machine is 24.5 inches over and 24.5 inches up, right? It keeps track of itself. So if I tell my part right now, if I tell my X to move over, let's say I want to move over 28 inches. If I tell my X to go 28 inches, it's going to travel that 28 inches, but I don't have 28 inches of travel. So I'm going to get a message that says you've reached your machine limits. Now I've only moved 23 because that's how far from zero, from my XY wood position, my zero, that's how far I've traveled, 23 inches. But on my machine, I am 48 1/4 inches over from my machine zero position. So it keeps track of itself, so it doesn't crash and things. So there's some benefit in there. So number one, you're not doing hard crashes, tearing up your machine. Number two, your soft stops, your soft limits and everything that you can set, those will easy recovery. You know, if you reach your limit, it stops you and stuff. And I don't have to have limit switches on my machine to do this. I just have to have a fixed position that I home my machine out in the morning and the afternoon, that one position on my table that I always work from. And from that position, I can set coordinates, offsets, those G54s and G55s from that fixed position. I can set my soft limits. I can set, different safeties and things like that. And so I guess the concern I have is that I don't want to confuse somebody and they're like, oh man, okay, I'm going to have to learn everything all over again because I've never really worked with a work offset and all that. Well, technically, you've always worked with a work offset. When you're zeroing out your X, Y, and Z on your work piece, you're setting your work offset, right? But you're doing it, you might be doing it in the machine tab of your software, or you're just your main, X, Y, Z coordinate, position in your software. And you've never really, had to deal with two different home location or work location, right? And so the mindset is just knowing that there's a certain spot on your table that is your machine's position, your machine zero. And then wherever your work is clamped on your table, that's your work position, your work offset. And if one could set themselves up that way, you could use your 1, 2, 3 block to zero yourself out. You could touch off, you could use a quick set sensor. You could, you don't have to physically mount or put limit switches on your machine. Limit switches are great and everything, but it's not a requirement to be able to set up these coordinates and offsets. So let's look at and see how many people I put to sleep with that. Brooks Martin says, same way with WinCNC, except under the home positions menu, right? So, yeah. And Roger, thanks for clarifying a walking stick. That was a very cool walking stick that you made, man, with those skulls. That was awesome. But it is, what am I trying to say? It is something new that if you've never really worked, with those two coordinates, and now everybody, put it this way, I'm going to say everybody like I know, but most people that their machines, they home their machines, they're working with this system as far as setting their machine home position. They run their home procedure, and then they move over to their sheet of plywood, their 2x4, whatever it is they're carving on, and they're setting their work offsets. They're setting their works XYZ datum position, their start position on their material. They're doing that every day. It's part of their routine and everything. So for those of you that do that have those machines with limit switches and everything, one of the things that you might not be doing is utilizing the coordinate systems of your machine, G54 through G59. Are the 6 main ones, but setting and cordoning off certain areas of your table to work different portions and do different things. Now, the benefit, one of the things I was getting tongue-tied on about 5 seconds ago, is when you're working with a fixed position, a fixed home position on your table, not only can you set those soft limits and everything, but you can also set those parking positions, those G28, G30, so your machine knows where to go, because that's all based off the machine position. I can't tell my G28 to be at 36 inches along my X and 3 inches over on my, or 36 inches on my Y and 3 inches over on my X, and that be from a variable home position, meaning that that my board's clamped in the middle of the table and I'm zeroed out here. If I tried to click that G28 button and I wasn't working from a fixed machine position, then it would try to move 36 inches from my work zero, right? So setting that lower left corner or your work table and everything, that gives you the full table to work with your coordinates and all. But if you have that fixed position that you kind of start working from, then you can set parking positions and things like that. And everything is working from that location. So even though, just so you know, right, even though my work, if I bring my work back to zero here to this location right here, this work offset, let's zoom in and see that yellow dot on the screen there. That's my router, right? This position is 0, 0 for my work piece, but for my machine, for my table, my actual physical table, it's 24.5321 and 24.5321 on that X and Y. So from there, if I was zeroed out there on my work position 0, and I tell it to move to G28 that I set for G28, it's going to move over to that G28 position I set. Now, from my work location, I moved over -17 and up 15, right? But it knows that 36 and 3, because it's all based from my machine's location, right? It knows exactly where to go from my machine's location and everything. The machine keeps track of itself. So if I have that fixed position that I create, even though I don't have limit switches, I could put a fence there. I could just say, okay, hey, I could make a little jig that held my 1, 2, 3 block that I could touch off on. I could use my quick set block, whatever it was that you use to perfectly set that position, repeatable every single time. Then, then from there you can set those parking positions, those coordinate systems, and things like that. Now, another benefit is you might see this. Many machines that have ATC, automatic tool change, have this. They have what's called a fixed sensor, a tool height sensor. And to give you a general idea, if I pop over to Amazon and I type in CNC tool height sensor, tool height sensor, whatever you want to call it. Let's go and look at this right here. So this is what's called a fixed sensor, right? And this generally, with people with machines with automatic tool change, this is mounted somewhere on their table, and they can take their tools, they can go to their tool rack, pick up their tools, and they can measure their tool offsets, right? And their machine will keep track of the different size bits and links and things, so that when they're zeroed out on their work piece, they can go pick up a tool and the machine will know that tool's offset, the length versus the tool it started with, and everything, all the curvings and everything will be perfect, right? Or they could go to their sensor and measure each tool to set their Z, just like we do physically on our workpiece, right? And so having a fixed home position allows for you to let's see if I can find. Give me just a momento. I don't know why. When I try to find something, I have the darndest time. I thought I was organized. Yeah, there it is. Okay, so it's going to be in a video form, but we'll pause it. Let's go like this. And let's move this over here. Now, I don't have an automatic tool changer on my CNC. That's one thing I strive for one day. But if you look very closely in the back left corner, you'll see this black and gold sensor mounted there. And that is this sensor right here. This is the exact one. What that allows me to do is when I come over and I zero out my first bit, I zero out my X, my Y, and my Z on my workpiece, right? When I am finished doing one tool path and I'm finished carving one tool path, I can take my first bit out, manually change to my second bit. And in my software, we have a tool here called Tool Offset Measure Length, right? And so I can click that button, and based on my software's settings, it knows the coordinate to move to go back and touch off and set the Z on that sensor, right? So when I am changing tools, I just click that button. The router will raise up. It'll go over. It'll touch off itself. It'll do all the little math because, the different length of the bits and all will vary depending on where I put that router bit in. And then it'll come over and it'll start carving its second tool path and everything comes out. The zero is always, dead nuts on, right? Because it knows the height of that tool sensor. It knows, the length, when it goes and touches and everything, it knows that, okay, this is a little bit different. And it's setting that what's called that tool length offset. And so prior to having a fixed position on the CNC where I can home and it knows where to go back to get to that tool sensor to touch off, I wasn't able to do that tool sensor right on my 2440 and everything, not until I, set a fixed position on my table. So once I have a fixed position, there's those 1, 2, 3 blocks. There's both of them right there. But once I had that fixed position on my table, now I could mount a tool height setter or a Z tool or something, a fixed tool, not a movable tool that we use to touch off our Z's and stuff like that. We still utilize that. But now I have a fixed sensor that I could utilize if I want to. I don't have to, but if I wanted to, and I'm changing bits, I can just click a button. It'll go measure that tool, come back and start carving, and everything. It does all the calculations of the offset, so it makes it the zeros are identical, each time. You could the sensors aren't always 100%, perfect. You're off, you could be off by 1/1000th of an inch, here or there, but it's minimal. And so fixed tool sensors is another little benefit, even without automatic tool changers, another little benefit of having a fixed position on your CNC machine. I don't care if your CNC machine is a little Piranha, Shark, X-Carve, out, whatever. I don't care what the machine is, digital wood carver and all that. You can work from a fixed position on your table. You can say, okay, this bottom left corner, always work from that lower left, right? Or lower right, just as long as it knows what it is. But this corner here, as far as my machine can go on X and as far as my machine can go on Y, I'm going to come off. I want as much travel as possible, so it'll either be 1/4 of an inch or a 1/2 inch off that limit of travel, right? So I move off a 1/2 inch on X, a 1/2 inch on Y, and that position is my 0, 0. That's my machine's position. And from there, everything, all the coordinates are the offsets, all the coordinates of where my fixed sensors mounted on the table, all the coordinates of my G28 parking position and my G30 parking position, all hinge from that position. That's my machine's position. Now, where I clamp my boards on my table to carve, where I zero out my X, Y, and Z on the center of that board or the corner of that board or what have you, that's my work offset. That has nothing to do with my machine position. My work position is where my work is mounted on my table. But the machine keeps track of itself in its machine position. So I keep repeating. I'm not going to repeat anymore. Show of hands. If you understand, give me a thumbs up or something, or, what have you. And we'll go with that. All that stuff. All right. So Brooks, how does the fixed tool sensor, right? So that fixed tool sensor deal with a 2-inch surfacing bit, with carbide inserts and things. So the round diameter of that fixed tool sensor is about 1.25 inches in diameter. And technically I could, if I wanted to, create a code that would offset the bit to go over and touch off on the inserts and things. You can check out Hermberg. What is it? Maurice Hermberg. He kind of explains that a little bit better than I do. But my surfacing tool, I don't use the fixed sensor on. The surfacing tool gets zeroed out on my movable tool sensor. I have a movable tool puck that comes down. It touches, and then I can set I have a button in the software that I click called measure height, and the bit comes down and touches off and goes from there, right? So I don't use the fixed tool sensor on I have a 2-inch surfacing tool that has 3 or 4 inserts, right? And there's nothing in the middle, so there's nothing to touch off with, right? So that's how you deal with that. All right. Cool. So mind blown, Kool-Aid said. Guess yeah. And so Ronnie and I, let me bring the guys back up. Ronnie's JR, Ronnie, hopefully I didn't put y'all to sleep just yet. Let me bring you up for a second. I was talking to Ronnie earlier. Let me get myself big here for a second. Got to find that right button. Okay. I was talking with Ronnie earlier. Where'd y'all go? There y'all are. And Ronnie has a wonderful shop set up, and he makes some beautiful boxes and things. And his box parts, he's created a system for himself that just like the jigs you might have seen on my table in that little video and all, that his box parts drop into. He knows where to go to carve those parts out, whether it be his lids or his sides and things like that. And if I'm not mistaken, Ronnie, you correct me if I'm wrong, you use melamine for that? Melamine sheets? Is that true or false? Oh, hold on, Ronnie.
Sorry, I was on mute there. Yeah, I'm using I'm using a piece of 3/4 inch melamine.
Is it melamine? Yeah, because it's beautiful. And you also V-carve information next to your pockets, right? So you know what's what.
Yeah, because I carve on both the top and the bottoms of those lids.
Yeah.
And so it's to make sure that when I'm flipping those over, that I'm orienting the hinges. I put on there north and south. It's just something that means something to me. Probably wouldn't.
Sure, right. And so what Ronnie has is on his CNC machine, he's got this piece of melamine that has these pockets cut in that he drops his parts right into. They're labeled, each of those pockets are labeled of what the part is, so he knows. And then, like he says, he knows which is north or south as far as what part of the lid he's carving on, and it's just a great system. And when Ronnie and I were talking earlier, I don't think, Ronnie, that you're using coordinate systems. You're using the Vectric software to help. The Vectric knows where that layout is because you're using your jig as the template for your tool pass, right? Correct.
Correct. Yeah. When I set up my sheet in Vetric, I set it up as 48 by 96,
Yep.
3/4, and then I take all my components, create an array on there, and then do an offset around that so that I've got a little room to slide those pieces down inside. Still tight. So
Yeah, exactly. Yeah, and that's the thing. Like with my parts, like my HDPE parts on that one jig, my offset, right? My pocket offset, I use for me, it's a negative 0.008, and that gives me it's almost like you can there's a little bit of an air pocket, like it just slowly sinks down, but it's not it pushes down nice and easy. It's a little bit of a friction. I've got little parts that go and hold and clamp it down, but it's a nice fit. There's no wiggle room, but I'm not beating the parts in and stuff. So those offsets are cool. Have you ever, and this is where I was asking, you were answering me. I'm putting you on the spot. Have you ever looked at or tinkered with the possibility of on your jigs and stuff, like creating coordinate systems on your physical machine?
Yeah, I actually do. But what I'm using it for is that I hate every time I change a jig out or something, I have to go back over. I have a tool height sensor that's already built into my shop table.
Yeah.
But then for my Z0, I hook it up to the side of the spindle, and I have to come down. And you have to be careful with the movement. You don't want to go too fast, or it'll slam down into your workpiece.
Yes.
And then going slow. And I don't have a remote to dial that stuff in. So what I've done is I move everything over where I'm usually going to be touching off for Z0, and I program in those coordinates. So I just go and click it on, and the machine will move right over there, right above it.
Yeah, and your shop saber has a very cool. It's pneumatic, right? It's those pins. Yeah, I love those pins. I don't know. I think they're called alignment pins or something like that. But alignment pins. Ronnie has a shop saber, and he's got on his table, he's got these pins that pop up, and so they're like that fence I was talking about, like a fence system, like a place that your wood or work always references from. He's got these pins where he can just align pieces up, bam, 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 and they land. I mean, it's pretty much dead on every time, right? I mean, that's that is your fence. Yeah, cool stuff.
Exactly.
Yeah, it's pretty cool. And it doesn't take a whole lot of Ronnie, do you have automatic tool changer on your machine?
Yeah, I've got a 10 position ATC.
Yep, yeah, we have, and pneumatic as well, right? But it doesn't use like for those that are, it doesn't require a whole lot of air pressure. It's just a small amount to open up the clamp to grab the tools, close it, and for the pins to come up. So it's not like you have to have a massive, shop system and all that. And it's cool stuff. Very, very cool. Let's see here. Any tips on cutting plastic or HDPE blocks? I cut 4x8 sheets of HDPE, half-inch thick is what I work with mostly. My sheets are half-inch, but I make dust brushes, 4-inch dust brushes, and the O-flute bits. I use O-flute bits, hands down. I use a combination of 1/4-inch, 1/8-inch, and 1/16 inch. Really, there's no trick to it. I mean, even my 1/16th of an inch bit is running, 100 inches a minute. HDPE cuts like butter. As far as tips, a good cutting for HDPE on 1/4-inch bits. A good speed, 16,500 RPMs at 100 inches a minute is a good speed for nice cutting. That 1/8-inch bit, 100 inches a minute at 18,000. And then I'm spinning 16.5 again on my 16th inch bit, and I'm running 100 90 to 100 inches a minute on that. I don't really have a whole lot of tips, but if you've never cut it, it cuts beautifully. It's plastic, right? It's king starboard, whatever you want to call it, HDP, high density polyethylene. There's all kinds of different different plastics and all, but Kool-Aid, I don't really have any like magical tips and all. I make one thing out of HDP and I do very well with it. And you know, the they have not been they're not out there in the public eye just yet, but hoping they will be soon. Let's see here. Let me see if give me just a second. No. This was the very first prototype. Oh my goodness. Let me see if I can do one better here. My drive. Give me just a second. Manufacturing 4848. Yep, right. Okay, I'll play this. This is okay. I'm laughing at myself, but anyway, let's go over here. Okay, and let's do this. Let's make it big. All right, so this is dust brush. Excuse the mess in the shop, but that HTP, I'll tell you what, it goes everywhere when you're not using dust collection. But this is my dust brushes. They're designed to fit on 80 millimeter and 100 millimeter spindles and everything with a 4-inch dust port. They're magnetic and all. And the funny part about it is this is a video I was showing someone that how well they work. And after here right now, I'm getting ready to stick the brush on, and I wasn't paying attention. I was trying to talk. There's no hot glue. Most brushes are hot glued in. This brush is interchangeable, but there's a groove in there, a T-slot. But in the video, I am about to demonstrate the magnetic and ease of putting it on. Right, and here I'm just talking, and I drop it. Right, so I had to explain that was on me. That wasn't by any means the the quality of the part. But this was the prototype, and now all the edges are rounded over, nice and smooth to the touch and things like that. But that's what I make, right? So that's one of the parts that I make, and that's all I cut Kool-Aid out of HDPE. That's all I work with. And now one of the other things I'm going to start making are plenums for vacuum tables for CNCs, and also holding type jigs and things. I don't know if I'll make those out of MDF or the HDPE, but we'll see how that goes. But I'm all about, my thing is, even though I work with digital wood carver, I handle all sales service of digital wood carver. I love R&D, and I try to I look at what's out there in the CNC world and try to fill a gap, right? And try to provide. I want to develop products that CNCers can use, and and all kinds of things. And we'll see what I can come up with in the world. I need to put my stamp on the CNC community somehow or another. All right, so but that's all I do with the HDPE Kool-Aid, and so I don't have any master magic tricks or anything like that. And y'all didn't see any of that, did you? Because of my big ass head being in the way, right? that whole time, I didn't even realize that I was still. So hold on a second, guys. Y'all didn't see any of that, did you? That was great. Let me move my head out of the way just for a second. Let's kind of just briefly recap on that. I can't believe I totally spaced on that one. Can y'all see that now without my head in the way? So this is the dust brush that I make. It's a 4-inch dust brush, HDPE, magnetic. And as I was saying, you probably didn't see with my head in the way, but when I was demonstrating how to put it on, I dropped during the demonstration. But it does work very well. Magnets hold strong and everything, and I had to prove it that second time around. But that was my prototype, and they're designed for 80 and 100 millimeter spindles. But that's all I make. Kool-Aid. Sorry, I thought I was showing that to you, but my head was in the way and everything. So, yeah, that's my little dust brushes. All right, cool beans. All right, so let's kind of get into. Let's see what else we have here as far as questions and stuff. Slow spindle and fast feed rates, right? I mean, I'm running 16.5 for my bits and 18,000 RPMs. I'm not going really slow, and I'm getting really nice chips, as you saw. I don't know if you saw on the table in that video, but quite a few chips, and they're doing very well. So. O-flute bits are a must. If I broke my 1/8-inch bit, let me tell you what my mistake was. All right, so I have these 1/8-inch O-flute bits and everything, and I was going to zero out my Z on my fixed plate. Now my movable sensor. Now I took my movable sensor from my CNC and I switched it out with a 1-2-3 block. Because when I zero out on that 1-2-3 block, I mean, it's dead nuts, right? There's no ifs, ands, or buts about it. But there's a magnet that connects to the 1-2-3 block to basically power it up as a sensor. And I was talking with someone trying to give them support on the phone as I'm zeroing out this 1/8-inch bit, and I'm lowering the bit down, and all of a sudden I'm hearing crunch, 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 and I look, and I'm just snapping it. I'm just crushing it into that 1-2-3 block. I forgot to put the magnet on it, so there was no sensor signal telling it to stop. So don't do that. But anyway, so I broke that bit, but I had to make some parts. I had to get some of those parts out. And so I used a regular 2-flute upcut, spiral bit. Major difference. O-flute bits when you're cutting plastic. I'm a big advocate of O-flute bits, and I cut aluminum parts as well too. O-flute bits for aluminum parts. Yeah, it's crazy. So let's see here. Hey, John Thompson, welcome, John Thompson. I haven't even seen John Thompson. How you doing, buddy? Lainey, did you ever finish the removable worktop for the hydraulic lift? I have a half of a worktop. It's like a skeleton without its skin and everything for the hydraulic lift, but it has not been finished. It got put a little bit on the back burner. One, because I don't know if you saw the pictures of the shop, but there's no room for that. It's in my big shop, and there's not a whole lot of room. And so it got put on the back burner for a bit. But I want to say it is 86% done. 86. It's the framing done, but not the top parts and stuff. It got put on the back burner. If I ever finish that, I'll let you know. Let's see here. No, Brooks Martin, will HDPE gum up like acrylic? I will say this. If, like when I'm doing my T-slots with my T-slot bit for my brush part of that brush, if I am building, if I'm moving too slowly and everything in that and stuff, and my bit is building up heat, it's taking those chips, those shavings that are supposed to be flying out, and it's literally heating them up. And HDPE has a very low heating point and everything. It's great for injection molding and stuff like that, but it'll heat up. It'll travel up the bit and create a molten ball. And then when it cools, it's like a rock, right? And so now your bit shank is trying to get through this slot and everything as it gets deeper in this molten ball there. So you got to be careful of that. So to help prevent that, I have air assist, if you will. I have a little nozzle, a flexible nozzle that's blowing out air, and it's kind of helping blow those chips away so they don't come up. But even that's a little bit tricky, because if it's too much air and I do end up building heat up on the bit, all that air does is rapidly cool that melted plastic, and it makes it it turns it into a solidified rock instantly. So there's a little bit of, I'm not an expert by any means on HDPE, but there's, don't build up a lot of heat, because it does have a low heating point, melting point, but it doesn't gum up and everything unless you're wrong. You're building up heat on your bit because you're running too slow or stuff. What kind of vacuum system do I use? So for vacuum clamping, I use the black box vacuum systems. They have the Storm, the Cyclone, and the Hurricane. I use the Storm on my 2440. I'm eventually, because I have a 4848, I'll be getting the Cyclone for my 4848. But my Storm, not only is it using for vacuum table on my 2440, I have it on my 2440 for vacuum clamping and everything. But when I was at IWF in Atlanta last week, Black Box Vacuum had a booth there, right? And they were demonstrating vacuum clamping, but they didn't have a CNC machine there. They had a work table, almost like a downdraft table for sanding, but they had, it had basically kind of a tabletop on it and everything, that MDF top that vacuum could pull through. They were throwing boards on there. They were turning on the vacuum, and it was holding those boards down. And a light bulb went off, and thought, oh, hell, I'm going to put a T on my plumbing that's coming from my black box vac going up to my 2440. There's going to be a T and a blast gate, and it's going to go over to a clamping table for when I'm hand planing or I'm sanding or I'm doing whatever. I'm building a work table that will vacuum hold all my pieces to it when I need, instead of like clamps and stuff like that. So if I can work it with tools and chisels and this and that and things like that, I'm making a vacuum table, and my Storm is going to be the tool that sucks that stuff down too. But I use the Storm for that. Now, as far as dust collection, I have hold on. Oh shit! It is a Fox. Oh, come on! Hold on a second. Fox dust collector. Shop Fox. It is a Shop Fox, and it is basically it's this guy right. Where's he at? Right here. By Grizzly. If I pull this over, it is this guy over here on the right. And I took the legs off. Those legs are shit. Oh, they're just terrible design, Shop Fox. But anyway, and I have it mounted in the corner of my shop. This is mounted, and then all of that stuff comes underneath. But I took those legs off, and it's fixed in this corner of the shop. I built a platform that holds the motor and everything. But that's what I have for dust collection. And I also have a Laguna dust collector, but it's not in use right now. It's in my big shop, in waiting to get put into production at some point in time in life. So that's what I use. And then what was the next question? Laney, you mentioned R&D. What is that? R&D, research and development. It's basically, like when you're prototype. I love prototyping. I like making things. I love making jigs. I love making tools. And research and development, right? Research and development. So that's what R&D is, research and development. So I like making things and functional things, and then one of those things are going to one day go to the market and make me millions of dollars one day. Who knows? You never know. Let's see here. No, your big head was in the way. Someone said much better. All right, let's see here. Let's see, research and design. Research and design's another term for it. Yep, John. All right, so that's it. What about PVC board? Now, I've never carved PVC board, but I do use PVC board on my plenum, my vacuum plenum. I use PVC board to block off areas of the table, so because the vacuum doesn't go through. So when I'm working on small parts and everything, I use half-inch PVC board to block off certain zones of my table so all the vacuum is concentrated in those small areas. I love PVC board for that. But now PVC pipe, I used to make lithophane light lamps from 3 and 4 inch PVC pipe and things. But I haven't carved PVC board, but I use PVC board. It comes in over it. I go to Lowe's and it comes in different size sheets and everything. I get mine in the 24 by 48 range, and I use that for different things and all. Mostly it's my vacuum plenum. What's that?
It cuts pretty much the same as Starboard.
Yeah, I'm assuming it does. Yeah, because it's really lightweight too. So
yeah, I use a lot of the PVC boards for some of the jigs that my client uses for her weaving stuff.
Yeah, and then right. Do you get? Is there a certain place you get yours? You get yours from Lowe's and Home Depot too. I mean, I get the white stuff. It's called PVC board, but it's from Lowe's and Home Depot. So
yeah, it's the PVC trim board stuff.
Yep, nice. Let's see. That was all the questions and everything. I think. Let me see here. Did Ronnie Probert? Yeah. All right. So that is it. So great questions, guys, girls. But I don't want to leave you confused. So let me just say this. Take a look at whatever CNC machine you have. And if you're digital wood carver owners, if you own digital wood carver CNC machines, and anything I said tonight kind of, intrigues you or anything, reach out to me. I'm happy to work with you one-on-one to, kind of explain what I was talking about as far as setting up a fixed work position on your table if you don't have limit switches and things like that. For your other folks, unfortunately, I'm not really all up on Mach 3 or carbide, not carbide, but carbide motion and other controller softwares. But coordinate systems, G54 through G56, and then G59, not G56, and then 59.123 all the way up. That's universal, right? That's in the G code. So check it out sometime. And again, if you have questions, you can always throw them in the comment section of this video, and I'm happy to answer and stuff. Now, next Thursday, I'm on Thursday night, ladies and gentlemen, the public class. We're going to be talking rotary axis. Okay, I'm kind of getting into rotary axis a little bit, not like carving and stuff, but just like the setup and the use and most CAD CAM we are our Y axis or our X axis is our our rotation and stuff. And in some CNCs, it's the A axis, and the A axis, A, B, C are they're degrees. They work in degrees, 0 to 360 versus versus our units and our CAD CAM that works in X and Y as far as X, inches per distance and things like that. So a lot of stuff that I'm doing with rotary axis and all, and we're going to have a discussion on rotary axis next week. Vectric back in 2000, or not 2000, but back in version, I think it was 10.5. Somebody correct me in the chat if I'm wrong, but I think it was somewhere around 10.5 that they introduced inverse machining, G93, inverse time machining, where basically it's based on time, to get from point A to B in 1 minute, 30 seconds, or what have you. Do this cut in this length of time that's set by it's called inverse time, versus inches per minute. It's based on it can go this many inches within a minute. You know what I mean? That kind of thing. And so we're going to talk more about that. And I'm down that rabbit hole, and I really want to just kind of take what I'm learning, pass it along. It might be useful to those of you that have rotary axes and you haven't really gotten into them and you're looking to get into them. We're going to have a little discussion on rotary axis next week, so be sure to join me. All right, everyone. That's all I got tonight. Yes.
Before you check out, question for you. Under Planet, is there a feature that will do a pop-up note automatically the way that Vectric does?
For notes like your G-code notes and stuff?
Well, anything that I want to put in there. Since I'm not the only one who runs my machines, and with looking in and using work offsets and everything else, I want to put up a note going, hey, did you check your work offset? Are you using the right one for the right part that we're running?
Right. All right. So now in Vectric, you would actually put that in your notes.
Yep.
So it's part of your toolpath. So that way it would appear at the top of the G code, and also in Planet CNC. Now, if I close it, what your main window usually looks like is what you see on the screen here. But up at the top, there are these 3 boxes. In the middle box, if you click on it, it opens up what's called the output window. Now, in the output window, basically, if I'm running something, right? Let's say, for instance, I'm running a job. Let's get out of this for just a second, and let me go to desktop shortcuts 5100. So in here, if I am, let me get in simulation mode. And let me run. Let's run. Let's go to Lexar IWF, which is right here, and run this. In the post processor, I have areas here. I don't know if you can see that where it says print.
It's
Where
hard.
I can have whatever it says in print here will show up here. So when I run this job, you'll see that, let me pause it right there. This first part, ATC post processor job started, toolpath started successfully. That's the message that shows up. And then it shows the tools that I'm using. It would show a coordinate offset that I would be using and everything like that. I could have pre-programmed in my post processor, right? So that it does pop up here. And every stage of this, when the it moves to safe height, the tool change, the ATC enabled, it loads the tool, all that stuff is printing out, right? But at the end, I also have on my post processor, I have it where it manually prints that the toolpath was completed successfully. So when it's finished running in my output window, this is called the output window. When something is happening, like right now, it's getting ready to load the second tool and things. It is there's no sensor there, but I'm in simulation mode, so it's going to run through like it is. It goes through, it's going to take off, it's going to measure all that stuff, and then at the end of the G code, it's going to print out like the dust brush retract. So we have there's no tool loaded, so it can't measure. So that's from there it zeroes out, right? It's going to stop the program because there's no tool to measure. I'm in simulation mode, but at the end of the code or at the beginning of the code, I can make it print. I can have it print certain information and stuff. So that's one way. Now, as far as the output window under help, I can show, I have a log here, but as far as the output, let me go to program. Give me a second. View. Show.
Oh, basically, yes, there's a way to do something like that, but not automatically.
Not automatic, no. So you have to program your post processors. Like if it says G55, that it pops up, print this message, or make sure you're in coordinate system. But if you have G55 in your G code, it's automatically going to switch over to that coordinate system anyway. So as far as the manual thing, but your output window, you can have anything come up in the output window that you want, messages and stuff, as long as it's told to in the G code, I guess.
But that won't run until I hit the run button.
It won't. Nope. Yeah, it won't. That'll be the very first thing it does.
Yeah, that's the sticky part.
Yeah. Well, if you're using coordinate systems, it's going to switch. It'll be an automatic switch over to that coordinate system. So that print that pops up before anything happens, and it automatically switches. So if you're asking them, hey, are you using coordinate system this, it's already set. It does that automatically, right? So they don't have to, the operator doesn't have to change the thing, right? So
okay, that's
if I have G54, 55, 56, 57, 58, 59 at the head of my G code, when I save the toolpath in Vectric with that post processor, it sets everything off that coordinate system. So it runs off that coordinate system, and the machine will keep track of what coordinate system it's in, where it's located, and all that stuff. And it'll go home and all that stuff and everything, based on that coordinate system.
Okay.
So it does, it is pretty much, automated in some ways. But as far as the messages, that output's only going to print what the G code tells it to print.
So it's on me to make sure that I go in and I alter my post processor.
Yeah.
For my
and up
stuff.
here up here on line 13, it's blank right now because I don't have any notes there, but there can also be notes right there. And those notes are in like if I type in, a note here, then that's going to show up in the G code under line 13 at the top of the G code. It'll be there in notes. So you would train your employees to make sure they look at the file details and look for any notes, that you might have left them. And that's before they even hit start, they have to go over and read their file details, and they're looking at line 13. It's always going to be line 13.
All right, so I'm going to have to change my workflows because right now, with my one customer that I do, tons of different parts for, I've created the G code, I save it, and that's the only thing I let my operators have access to is, okay, am I running the 10-inch circle, the 9-inch circle, and they check that, load the material on, and just go.
Right. And in the header, like this is the post processor right here. This is the post processor file, right? And so in the post processor, in the header, is where you can add in any parameters that you want to show up, like in this case, file notes. So anything you put in the notes section here under edit notes, anything you type in here, when you calculate and save your toolpath, it's going to show up in that note section of the header. Before you run anything, that always comes up right there in the notes in the G code. Now,
okay.
From there, if there's anything that you have in the post processor that you want printed and you created this print area telling it to print, then that'll just show up in the output window. But notes, like if we look at this G code here, if I came in and let's say that I'm running this job, right? And I come into notes and you only give them, let's say you only give them access to the G code, right? So, in the notes here, I'm going to say, make sure you are working in G55, just as an example. G55. Or however you want to say it, coordinates. And I don't know why I got my cap locks on, but coordinate. I love spell check. Hold on a second. Coordinate. There we go. Coordinate system 2, right? And oops, let me get system there. Now, when I save this, now if I put a period in front of this, if I put a period in front of it, then anytime I open this project, so let me close out of this. Anytime I open this project in Vectric, it's going to pop up that note, right? So that note is always going to pop up as soon as I open the project and everything, right? But if I save the G code, let's say I'm just going to, just as an example, do a V carve, and I'll calculate that. Save that toolpath. Let's get out. Hold on. Let's get out of wrap. Hold on a second. G codes, helical arcs. Save and sample note. And I hit save. Well, when I go and open that, oh, hold on. I'm in ATC. I gotta save it with the ATC post processor. Give me just a second. ATC. There we go. One more time. Okay. Let's go in there and go file open. Downloads, sample note. When it opens up, line 13, make sure you're working in G55 coordinate system number 2, right? That's always going to be there. As soon as I import or open the toolpath, it's going to be in the notes section, right? Okay. So, it could be, it doesn't have to be one line. I mean, it could be a damn paragraph. It's gonna populate. It'll put in the note whatever it needs, and it wraps and stuff. And things like that. And all. So that's pretty much that. Let's see here. We have Brooks Martin. So you're hard coding the G code, the offsets, and do not prompt a user warning. Hold on a second, Brooks. Let me see what you're saying here. So you're hard coding the G code, the offsets, and do not prompt user warning. If I'm hard coding the offsets in my post processor, then it's going to switch on my screen as soon as I load that toolpath. It's going to switch over to that G55, G56, G57 coordinate. And on my screen, I will see it physically move over to that location where it's at, and I'll be zeroing off there and everything. Now, you could pop in some kind of warnings or whatever you want to do, but I don't need to do that, right? Because I work for myself. So I don't need to tell myself or warn myself anything like that. But I always, when I know what jig I'm working off of, I know that my first thing after I home my machine, I switch coordinate systems, right? I switch from whatever coordinate system I need to be on that table. If I forget to switch coordinate systems, no worries. My G code will do it for me, right? It'll switch me over. So I know I'm working off that jig, and I know I'm zeroing out my X and Y and all that off there. And if I forget to switch over and I'm in G54, it'll switch me over to G55 when I load the G code if I forget. So
Yeah.
let's see here. And that your user puts the piece on the right jig, right? Well, yeah, that's what training, definitely, Brooks. That's what training, you got to train them. All right, ladies and gentlemen, think about it, look at it, research it a little bit more. Research CNC offsets, machine offsets, not the offset in your Vectric software, under the job setup, use offsets, but your G54 through G59. Check out those offsets in your motion controller and think about stuff like that. If you don't have limit switches on your machine, think about setting up a fixed position on your machine. If you get lost, you can always ask the comment or question in the comment section of this video. I'll answer for you. Or if you know me on Facebook, reach out to me on Facebook and stuff. All right, Ronnie, let's see here. Let me say goodbye to you guys. JR, Ronnie, y'all have a wonderful evening. Everybody, thanks for all your questions and stuff. Just a little bit of, I don't want to leave you with more questions than we started with, but just a little bit of information of something to look at, something you may not have known about your machine or what you can do or something like that. Hopefully it just makes you ask questions and become a better carver, right? I don't know if it'll make you a better carver. You just know a little bit more than you did before you started, right? All right, everybody. We'll catch you later. Y'all have a wonderful evening. And until next time, we'll see you next week. We're going to talk fourth axis, rotary axis next week. Join me for that. Good stuff coming ahead. All right.
Thanks, Laney. Good night, everyone.
See you later.
Have a good one, guys.
Y'all can stay.